So this is the last method to prove the area of the circle using polar coordinates. We have two ways. So in the first way, you draw the circle and of radius r. You take a small sector with angle d theta, and what we are going to do is find this area of the sector and we will sum it up to get the area of the circle. So this area of the sector will be, I can assume this as a triangle, or you can directly write the area of the sector formula of r square into d theta. If you don't know it, we'll go it by assuming this as a triangle. So if you assume this as a triangle, to find the area of this small sector, it will be half into base into height, half into our base is r into this height. I'm taking it as the arc length, so arc length is equal to the radius into that angle r into d theta, so that will be r d theta. So now area of this small sector will be half r square d theta. So to sum it up, this is polar coordinates. You can directly use the limits 0 to 2 pi and integrate this function, so you will get the area of the whole circle. So area will be integration of this whole function, or the area of the small sector. We are summing it up so that to get the area of the whole circle, the limits are from 0 to 2 pi. Now it will be 2 pi, 0 to 2 pi, and 0 will get 0, so directly you write 2 pi into 2 pi. This will give us r square. So this is one way, and in the second way, you need to take a small sector similarly. So but here we are going to double integrate this small area. So firstly, you take a small sector in this way with the arc length r into this d theta. This is the arc length, so we don't need up to the circle. So in the circle, if you take this sector, so now we are accumulating some area. This is our accumulated area of thickness dr, and this area is dA. Now what are we going to do is we will double integrate this. So how we are going to do is, firstly, this small accumulated area looks like a rectangle. So small accumulated area is a rectangle. So the area of the rectangle will be product of two adjacent sides. Now I have dr and r d theta, dr r d theta. So this is r into dr d theta. So now what are we going to do is we need to double integrate this to get the area of the circle. For that you need to know the limits. So we are making this small thickness which I written as dr, defining it from 0 to r. Also the small theta right here, we are defining it from 0 to 2 pi. So we may even call them as some angular radius or angular distance. So this, the limits of this is our angular radius. It is going to be r, also our small angle 2 pi. So limits will be 0 to So okay, our radius is r, 0 to r, and 0 to 2 pi. So let us put it there. So now I'm writing directly. The area will be double integral of this function dr d theta. So the limits, I'm going to write the limits, 0 to r, and the one is 0 to 2 pi. So now if I solve this, let me first solve the theta. So it will give me 0 to r, r theta, the limits are 0 to 2 pi to dr. So if I substitute theta, I will get 0 to r, 2 pi r, 2 pi r, 2 pi r dr. This will give me 2 pi r square by 2.10 to r. So if I substitute there, I'm going to get, substitute 0, it will be 0. Substitute the upper limit, it will be r square by 2. 2 gets cancelled, and we will be left with pi r square. So these are the total 6 methods to prove the area of the circle.